In our last video, we used the Black-Scholes Option Pricing Model to find the value of a call. And in this one, we're just going to continue that video with the value of a put option. Again, we start with the Black-Scholes Option Pricing Model, found the value of a call. Our example that we were using in that situation was we had a stock price of 62, exercise price of 60. Time to expiration was 40 days, so this option had a little over a month. Remember, whenever we convert time into our option pricing model, we have to convert that to number of years. So 40 divided by 365. Our volatility, our anticipated standard deviation of the option was 32%. Convert that to a decimal, and the risk-free rate was 4%. And again, we want to convert that to a decimal. When we walked through that example, we found that the value of the call option was $3.72. So that was our value of the call. Now in this video, we're going to do the last part, which is find the value of the put option. Now in order to find the put option, we start with the value of the call. There's a relationship called put-call parity, which means the value of the put contract is going to be directly related to the value of the call contract. So we first of all find the call, and then we go to find the value of the put. So our formula for the value of the put is equal to the value of the call plus the present value of the exercise price minus P0. Again, you might remember this from our value of the call formula. X divided by the exponential to the risk-free rate times time. I refer to that as the present value of the exercise price because that's all this is doing, is finding the present value of the exercise price using continuous compounding. If you want to, you can set your calculator to daily time periods, find the present value of the exercise price using your 5-key approach. You're going to come up with the same answer. So our previous example, remember we said the value of the call. We solved for that and got $3.72. So plug that into our value of the put, $3.72. Present value of the exercise price, subtract off current stock price. So $3.72 plus $59.74 minus 62 gives us a value of a put of $1.46. So in this example, our call, remember, is $3.72 and our put was $1.46. Now that makes sense because remember our stock price was $62, the exercise price was $60. So this call option was in the money. It had an intrinsic value of $2. So our speculative premium then is $1.72. Intrinsic value $2. Speculative premium $1.72. The put option was out of the money. In order for this to start having some intrinsic value, the stock is going to have to fall by $2. Remember, a put option gives us the right to sell at 60, so that's not going to be valuable at expiration unless the stock is below 60. So right now it has no intrinsic value. Intrinsic value is 0, so all the value is speculative premium. Oops, should be $1.46 for the speculative premium. Now you may look at those calculations and say, well, that's nice to know if I have a test on the Black-Scholes option pricing model for class, but as an options investor or options trader, I'm never going to spend the time to sit and walk through that Black-Scholes option pricing model by hand. It'll take me 10-15 minutes to get the value of the call and the value of the put, and by then prices will have changed. And that's a good point. Trying to do the Black-Scholes option pricing model by hand, especially in the day of spreadsheets and handheld smartphones and everything, is a waste of time. There are probably lots of apps on your smartphone that you can download that do the Black-Scholes option pricing model for you. If you want to, I've got a spreadsheet up on Google Docs that I listed in our introduction point there. Just tinyurl.com/brocker-bsopm spread, and that's an Excel spreadsheet that you can plug those values in. So if you want to go through that spreadsheet, you can just download a copy of that spreadsheet and go ahead and run through the same calculations. Now if you do that, you might notice your answers are slightly different. For this example, the value of the call turns out to be $3.86, and the value of the put was $1.60. No, that's different than what Ree came up with. Ree said $3.72 and $1.46. It's not that our calculations were wrong or the spreadsheet's wrong. Instead, it's that the spreadsheet doesn't round anywhere. So when we look up those ND1 and ND2 values, we have to approximate them. The spreadsheet doesn't. So the spreadsheet's going to give us more exact values. It's actually a little bit better if you're trying to figure out what exactly a call or put option is worth.